Okay, everyone. So we should start now. So we were discussing about what? We were discussing about equilibrium, right? We were discussing about equilibrium, right? So today is the last lecture of this equilibrium, and after that, tomorrow will be your what? Chapter assessment will be there. So I am giving you topic today, and you should prepare on that. Is it okay? Okay. Atacha, your topic is buffer solution. You have to speak on what? Buffer solution. Vishnu Priya, common ion effects. Please note this topic and make a note on this common ion effect, and you have to represent in tomorrow's class. Got my point? Bhuana, you have to see into what? Just a minute. Solubility constant. Solubility product and constant, right? Solubility product constant. You have to prepare this topic tomorrow. Got my point? Mukeswaran is here. Only 4 people. Yes, Vishnu Priya. Mukeswaran, for you, I'm going to give you a topic that is indicators. You have to prepare this topic for tomorrow's class, right? Indicators. You might be not be getting in your NCERT, and but you have to prepare that I have given you. Is it okay? Okay. Now we are going to see about what buffer solutions, right? So what do you say? What are buffers? Everywhere, like in our daily life also, we are like, let's suppose if you have to go to school at 6:30. So it doesn't mean that 6:30 means the class will start from the 6:30 only. There will be some buffers will be there also, right? Even when you are joining TZ, the timing is what? That is 7:30 p.m. But now I have started this class at 7:42. So it means that there is some buffer periods are there. Is it okay? So in the chemical reactions also, we are having some buffer solutions. So what will be the buffer solution if, let's suppose, we are having water, right? And we are having a buffer solution. Let's suppose you have water is what? A neutral you can say, right? Water is what? A neutral solution. And you have given what? Let's suppose some ml of HCl into this water. You have given what? HCl into this water. So this water will be what? Acidic in nature? Yes or no? The pH of this water will decrease or what? What do you say, guys? Let's suppose if you have poured what? HCl into that water, then what will be happening there? Can you please tell me? So water will become slightly acidic? Yes or no? Because why? And their pH will also pH will also decrease. pH will be also lesser than what? 7. pH will be less than 7. Earlier the pH of this water is what? 7. But after introducing HCl into that, then it becomes what? It becomes acidic. But let's suppose if you are having a buffer solution, even though if you are giving what? Acid, then what will happen? There will be a change, but there will be a change that will be a slight change. That let's suppose now, if the pH of this solution, let's suppose 7, 7.5, you are adding a drop of what? Let's suppose any acid, right? So there will be a decrease, there will be a decrement around 7.4, like that. But if you are adding water to this, if you are adding HCl to this water, the water pH will go where? Around 3 or 4. Getting my point? So buffer is what? Buffer is what? Can you think and tell me about what is this buffer? Will it resist a change in the pH or not? Please tell me that. Will it resist a change in the pH or not? Please tell me that. If buffer is a solution, you are adding what? You are adding HCl into that. then also the pH is not decreasing. Getting my point? Then also the pH is not decreasing. It means what? It is what? Registering the change of the pH. So can we call this buffer solution a solution where even after the introduction of acid or even base, the pH will not be affecting much. Getting my point? Is it okay? Ashwin Karthik, please turn on your camera. Bhuwana, if you have not heard what I can do, even I have also forgot that what I have given to you, because so many 5 people were there. I have given different topics to each and everyone. So Bhuwana, anyone is having any idea what topic I have given to Bhuwana? Indicators, I hope. Bhuwana, indicators. Right? Now guys, see here. We have seen in the last class Bronsted-Lowry theory, right? So about the conjugate base and all. Now, so what are these buffer solutions? Now we are going to see about the definitions. I have told you what is this buffer solution. I hope everybody has got this. What is this buffer solution? Any problem till here? Anyone is having any problem till here? No? Ashwin Karthik. Yes. So as you know that in every chapter assessment, I used to, you have to introduce any topic, right? So for you, I'm going to give you a topic that you have to prepare today, and you have to represent this topic tomorrow in tomorrow's class. Is it okay? Is it okay? Fine?
Yeah.
Yes. So the topic is what? For you, I'm going to give you a topic that is what? Arrhenius concept of acid and bases. Bronsted-Lowry acids and bases. These two topics you have to prepare. Bronsted-Lowry theory and Arrhenius concept of acid and bases. And there was one more scientist whom I have discussed in the class. So all those three scientists, like one is Louis acid and bases, right? So what they have told about the acid and basic natures, that you have to represent in tomorrow's class, right? Now, see about this buffer solution, guys. A buffer solution is a solution that resists change in hydrogen ion. Hydrogen ion concentration. Hydrogen ion concentration is what? H plus. Getting my point? H plus means what? Acidic in nature. If in any solution, if we are getting H plus ions, it means what? That solution is what? Acidic. So a buffer solution is a solution that resists change in hydrogen ion concentration when modest amount of acid or base is added. Getting my point? In other words, such a solution known as have reverse acidity and reverse basicity and keep reasonable steady pH value, right? So their pH value will be increase or decrease. That is very minute amount of their pH will be increasing or decreasing. Is it okay? Any problem till here? A good example is that is what natural buffer solution is human blood. Getting my point? So if we have to take the example, that is what? Human blood. Any problem till here? Getting my point, guys? Now, one more thing is what? Despite eating a wide array of meals, our blood maintains a pH of what? Roughly 7.35 pH. And this is what? Slight basic in nature. Slight basic in nature. Is it okay? Is it fine for you guys? Any problem? What is this buffer solutions? Any doubt till here? No? Okay. Then I'm going to give you one more definition about the buffer solution. If you want to write, then please make note of this. So are you ready for writing? Please have a note of this, guys. The solution which resists change in pH a solution which resists change in pH on dilution or with the addition of a small amount of acid or alkali, or with addition of a small amount of acid or alkali are called buffer solutions. Is it okay, guys? Any problem till here? No? Yes. Written, everyone? Should I repeat or have you written this? Okay. Atachaya, Mukeswaran, Guana, Aswin, written. Very less people have joined. Is there any festival in your in South India today? Are you celebrating Diwali? No. Guana? No Diwali? Okay. Okay, guys. So we will be seeing some more points about this buffer solution. What? Buffer solution is a water-based, solvent-based solutions made up of what? Weak acid and its conjugate base. So weak acid and what? Or weak base. See, guys. First of all, what? Weak acid and conjugate base. First is this. Second is what? Or a weak base. Now this time we are having what? Weak base and its conjugate acid I will be giving you some examples as well. So first write these things. So how we can prepare the buffer solutions? So first of all, what? Weak acids and conjugate base, or weak base and its conjugate acids. Getting my point? So they are resistant to change in pH caused by dilution or the addition of relatively small amount of acid or alkali. So if there will be addition of anything like acid or base or alkali, you can say, so they will be resisting the change. They will be not changing their pH value, or even the pH will be changed, then it will be only a slight change will be shown in that. Is it okay? Any problem till here? No. When a small amount of strong acid or strong basis is added, the pH of the buffer solution change very little. Getting my point? Let's suppose we are having this weak acid we are having, right? And its conjugate base will be there. Getting my point? Conjugate base will be there. But you are doing what? You are adding a strong acid, that is what? H2SO4 if you are adding. So there will be a change will be seen, but the change will be what? That is minute change will be seen in that. So the solution can turn into what? Let's suppose that if the pH is some around, let's suppose 7.2. So it will shift towards what? 7.1 or 7 only. Getting my point? Is it okay now? Any problem till here? No? Okay, guys. Now, as a result, they are used to maintain the steady pH. When a teeny amount of strong acid or base is given to its pH varies very little, and thus used to keep a solution's pH stable. So if you want to keep the solution pH stable, so we will be using what? Buffer solution. Getting my point? Is there any problem till here? So if you want to keep the buffer solutions, that is what? They're steady, then it will be called as what? They are known as buffer solutions. So buffer solutions keep the pH of the any solution that is steady, or you can say that there will be only slight change will be there. Okay. So what can be the examples? Can you think about the example for this? Is there anyone who can give the example for this? So guys, write the example for this. A mixture of acetic acid and sodium acetate. Mixture of what? Acetic acid and sodium acetate. Mixture of acetic acid, right, and sodium acetate, guys. Getting my point? So they will be acting as a what? Buffer solution. Any problem till here? No? So see here. CH3COH and CH3COONA. CH3COOH. If you will be seeing this, see guys, how we can write this? CH3COOH. What is this? Can anyone tell me what is this? We will be going to start our organic very, only 1 to 2 chapters we will be starting our organic chemistry. Then I hope after this you will be able to understand this what, yes, branched form, but what is the name of this? So see, acetic acid is there. So there is what? This is a weak acid and strong base that we are having what? CH3COONA. Getting my point? So combining they will be form what? See here. OH, H plus is there, right? So H plus, if this will give a very little amount of H plus ion. But CH3COONA, that is what? Strong base. So it will give what? OH minus ion. So see, it is a small. So what is this? It will give its small effects. It will give its high effects. So overall, the solution will be what? You can say that there will be a that the solution will become what? Buffer solutions. Getting my point? Is it okay, guys? So H will be removed from here, and what will be removed from here? You can see here CH3COO. So togetherly we will be getting what? We will be getting a buffer solution. So we have seen in case of what? Acidic, that is weak acid, and salt of what? Salt of what? Weak acid and strong base. Weak acid and strong base. Is it okay? Salt of weak acid and strong base. That is what conjugate. That is what we are saying that is conjugate. Is it okay? Now, about the basic, if you will be going to see what the basic. So weak base. Now this time what? Weak base we are having, and salt of weak base and strong acid. Salt of weak base and strong acid. Again you can see here, weak base and salt of weak base and strong acid. So H plus ion and OH minus ion. So finally we'll be getting what? NH4 plus and H2O. So NH4OH plus H plus ion. Getting my point? So what will be there? There will be a, you can see there that what we are going to get, that is, these all are what? Buffer solutions. Now, I hope everybody has written this definition. The solution will resist the change in pH by small amount of strong acid or base. Getting my point? See here, guys. We are having what? Again CH3COH and CH3COONA, right? So finally we are getting what? This is weak acid and strong base. Weak acid and strong base will make what? A buffer solution. Is it okay? Any problem? No. Here you can see what? This is what? NH4OH we are having, and NH4Cl also we are having, right? NH4OH and NH4Cl. So finally we are getting what? We are getting acidic and basic buffers. How they are combining and how we are getting this buffer solutions, that you can see here, right? Now, see, this is the third way by which we can make the buffer solution. This is what? See here. Again, CH3CONA is there. That is what? Weak acid and strong base. See, in case of salt of strong acid and strong base, salt of strong acid, strong base and weak acid. So we will be getting what? Strong acid. This is what? Here you can see HCl. Getting my point? Is it okay? So salt of strong acid and weak base we can take. So there are different ways by which we can prepare what? Buffer solutions. So what are the different ways by which we can make buffers? First of all, I would like to ask what are buffers, right? Who will tell me what are buffers? DRT, are you there? What are buffers? Can you please tell me about the buffers? Yes,
Sir, can you hear me, sir?
Yes, can you please tell me what are buffers?
Sir, it is a solution which resists change in pH by addition of small amount of acid or alkali.
Or alkali, very good. Anyone else who can give the answer for this question? DRT, can you please tell me what are these buffers? What are these buffers? Can you please tell me? Buffer solution. Yes, definition. Yes.
Sir, it is a change in pH.
It is not change in pH, it is resisting change in pH, right? So
Change
basically
in
what will, see, you were there in the class when I have started the session?
No, sir.
No. So listen please once again. So this time Atachaya will explain you what is this buffer solution, right? So Atachaya, please explain what is this buffer solution to Arthi. Guys, those who will be turning off their camera, I will ask them to explain the class, right? So don't turn off your camera. This is Ashwin Karthik. I am telling you again and again. Yes, Atachaya. You are not audible. You are not audible. Yes. No. So I'm going to give this task to Vishnupriya. Vishnupriya, try to understand DRT, what is this buffer solution? It's your duty that she should understand what is this buffer solution, right? It's your duty. And I will ask after this to DRT whether you were able to understand or not, right? Okay. Yes.
Should I, sir?
Yeah, you have to explain DRT. You don't have to explain me, right?
And basically, buffers are resist to pH change, and for real life examples of blood. And it's a solution that resists a change in pH by when we are adding a small amount of acid or strong base into the solution. The change will be a little when compared with the normal solution. And real life examples of blood. For example, when we eat a variety of acid and base foods, but still takes as 7.35 pH value, and these are typically have acidic base buffers, basic buffers, and other type is salts of acid, salts of weak acid and strong acid buffers.
So DRT, can you please tell me that what is this buffer now?
Yes, sir. Sir, the solution which resists change in pH by adding.
Even if there will be addition of acid or base will be there, right? Let's suppose I'm having this water, right? Water is having a pH of 7, right? Isn't it? But what you are going, if you have come, if let's suppose if there is a, if you're having a crazy mind, then you will be doing what? You will be stealing your acids from your school laboratory. That is SCl. Let's suppose if there is any crazy mind in you are having. So you have done what? You have just stolen the SCl from the chemistry lab, and you have done what? You thought that I have to do some experiment today at my home. So you brought that and you have poured in your what? Water. So what will happen? see, first of all, whenever you will be dropping a small amount of acid into the water, strong acid, so there will be exothermic reactions will be happen there, right? And after that, if you will go to see and check the pH of that water, so the pH of water will decreased. Why? Why there? What is the reason behind that? Because you have added acid into that water. Getting my point? So earlier it was having what pH? That was 7 pH. Water is normally having what? 7 pH, right? But the Virat Kohli, that water that they are having, water they are having, lesser pH. They are drinking alkaline water, so they are having lesser pH of lesser pH water they are having, right? So now this is one point that you have added that. But let's suppose if you are having a solution of strong acid and weak base. That is what buffer solution that you are having. In this beaker you are having what? A buffer solution, right? Buffer solution. Now you are adding what? Any acid in this. I'm not saying about the strong acid. If let's suppose weak acids will be there, or even the strong acids will be also there, then the effect will be seen very lesser. Here the pH will change from 7 to 3 or 4, right? When you will be adding acids into this water. But here what will happen, that the pH will be changing only slightly. PH will be changing. Let's suppose the pH is, pH of this buffer solution is, let's suppose 7.2, then it will change some around 7.1, or let's suppose it can be what? 7 only, right? So the change will be what? A minimal change will be seen in this case. Is it okay? So got what is this pH? So pH is what? So it means that this solutions have. So now you will be saying that how this solution can resist changes? Yes, solution can also resist changes. It will not change its pH. And even you are pouring what? In acid or base into that solution. Is it okay? Fine. Now, so we have seen so many examples of this. So try to remember from there. Now we are going to see about what? Solubility product constant. What is this solubility product constant? So anybody is having idea about the solubility product constant? Any idea if anybody is having solubility product constant? Guys, I am taking one example and I will be asking you for that, right? The example is what? See here. Then we will be coming to the next part, that is what? That is definition part. First of all, let's suppose if we are having what? If we are having a reaction, that is what? Reaction is what? AgCl, and this is what? At equilibrium condition, it is giving what? Ag plus Cl minus, right? Cl minus. If we have to find Kc for this reaction, so who will be telling me what will be the Kc for this reaction? Equilibrium constant will be what? It will be the product of what? Product of the product side upon the product of the reactant side. So it will be what? Concentration of Ag plus into the concentration of Cl minus upon the concentration of what? Upon the concentration of AgCl. Is it okay, guys? Any problem till here? What will be the see? What will be the Kc here? In this case, this will be the Kc. But if I have to ask you what will be the solubility or solubility product constant or solubility constant, right? They are both the same term, solubility constant or solubility product constant. So in this case, what will be the solubility or you can say what? Product constant, that is solubility product constant, that is what we are writing, that is Ksp. Is it okay? So Ksp, what is this Ksp? Ksp will be what? It will be only Ag plus, concentration of Ag plus into concentration of Cl minus. Is it okay? Is there any doubt? Is there any problem for this, guys? Please then tell me. What is this Ksp? Ksp will be what? Product of the product side only. That will be what? Concentration of Ag plus and concentration of Cl minus. Is there any problem to anyone? Any doubt? No. Now come to the definition part first. What has been given in the definition? The word solubility product refers to the inexpensively soluble salt. It is the greatest product of the molar concentration of the ions raised to their appropriate powers. So what is this appropriate power, guys? Let's suppose if there will be what? Let's suppose if I'm taking this example, and if there will be breaking into the 2, or here there will be, let's suppose, 3. So what will be their power? If I have to write this, so I have to raise to the power what? For Ag I will have to write 2 here, isn't it? I will have to write for Ag I will have to write 2 here, and for Cl I have to write what? 3. Got my point? For this I have to change this product as well, right? Any problem to anyone? How will be writing the, see guys, first write the formula for KSP. How we can write the KSP? The concentration of the product side, and there will be no, that is denominator will be not there. Getting my point? And their powers will be written, right? Their molar concentration, whatever be their coefficient will be there. That we have to also write in the powers. Getting my point? Is there any problem, anyone? No? Now see here. So, but here there is no stoichiometric coefficient. So I don't have written here the stoichiometric coefficients. Is it okay? Now again come to the point. So product produced by the compound dissociation, the solubility product is constant at any given temperature. The lower solubility product's value, the lower the solubility, and higher the solubility product value, the higher the solubility. If the value is greater, then the solubility is much. If the value is lesser, then the solubility is also lesser. Is it okay? Is it okay? Is it okay, guys? Any problem? If the KSP value is greater, it means the solubility is greater. If the KSP value is lesser, the solubility is also lesser. Any doubt to anyone? No? Fine. Now see here. Solubility product constant. See here. The solubility product constant is the equilibrium constant for the dissolving of solid substance into an aqueous solutions, right? It's represented by the symbol KSP that we have seen here, KSP. The solubility product is the type of equilibrium constant whose value varies with temperature, KSP. Typically rises as temperature rises due to increased solubility. So if temperature will be more, solubility will be more, then KSP value will be also more. Getting my point? If solubility will be more, if temperature is more, solubility is more, KSP value will be also more. So you can say that if temperature is directly proportional to what? So temperature is directly proportional to what? Solubility. And solubility is directly proportional to what? KSP. Is it fine, guys? Any doubt till here? Is there any doubt? Any doubt, then please tell me, guys. No doubt? Okay. Now we are having one example. Here, see here. Let us now have a solid like barium sulfate. This is what? Solid. See, these are what? These are solids. These solids are what? Sprangly soluble. Sprangly soluble means what? They are not much soluble. Getting my point? Sprangly soluble means what? They are not much soluble. So what we are going to see here? So it's saturated solution. The equilibrium between the undissolved solid and the ion in a saturated solution can be represented here. See here. If we have to find the K value, then what we will be going to write? Ba2 plus, concentration of Ba2 plus and SO4 2 minus, right? If we have to find K or Kc, you can say, then what you will be going to write? Ba plus 2, concentration of Ba plus 2 and concentration of SO4 2 minus, right, guys? Upon what? Upon what you will be going to write here? Upon concentration of BaSO4. Upon concentration of BaSO4. But you don't have to find K. You have to find what? KSP. Again, you can see here what has been given here. If you have to find the concentration, then for a pure solid substance, the concentration remains constant, and we can write what? That is KSP equals to what? K into concentration of BaSO4. BaSO4, that is what? And if this is equals to what? Concentration of Ba plus 2 and concentration of SO4 2 minus. Is it okay, guys? So you can see here, there is no anything in the denominator part, only the numerator parts are there. Is it okay? Only the numerator parts are there. There is no denominator part is there. But in the case of Kc, if you have to find Kc, then what will be there? There will be what? You can see here, there is a denominator part is also there. Is it okay? Okay guys, now. Okay, now we are going to see about the what? Significance of solubility product, right? First of all, I am going to give you one question and then please tell me that what will be the relation that we can get from this, right? See here. Question is what? We are having AgCl, right? AgCl we are having, and this will be, there will be what? Backward and forward reactions will be there. So it will be broken down into Ag plus and Cl minus, right? Let's suppose we are having what? Initially we are having what? Some concentration, but after that we are having what? So this will dissociate into what? That is S into S. S is what? This is concentration. Earlier it was having some concentration and here it was having what? 0, 0. That is no reaction was there. But after dissociation it will be what? Having S and S. Getting my point? So if we have to find Ksp for this, so the Ksp will be what? We are having what? S amount. Concentration of Ag plus is what? S. So Ksp will be what? S concentration of S into concentration of Cl, that is what? S, right? So Ksp will be what? Ksp equals to what? S square. Can we write this S square or not? Please tell me guys. And if we have to find S, then can we write under root Ksp? Can we write this or not guys? Please tell me. Is it okay? Anyone is having any doubt, then please tell me guys. So if you have to find the value of S, so how we can find? We can find under root Ksp. Is it okay? So please have a note of this guys in your notebook. Yes, Vishnupriya, please tell me.
S value will be same for both Ag and Cl, sir.
Yes.
In a reaction.
Yeah. I am saying what? There is some amount of AgCl is there, right? After dissociation, see, earlier we were having what? 0, 0 mole, right? But after dissociation, we are having what? See, we will be not using this AgCl, whatever be the amount of AgCl is there, right? So we haven't written anything in the denominator. That I am trying to say you from very beginning, right? Because there will be what? This is known as what? Solubility product, or you can say what? Ksp. The numerator part will be there. The thing that you are asking about the AgCl, that is what? That should be in the denominator. But in case of Ksp, that will be not coming in the denominator. That is coming in Kc part, that will be coming in the denominator. Is it okay? Is it okay, Vishnupriya? So guys, please try to note this S. What is this S? And then please tell me. After this, you have to write. See guys, if you have written, then please write in the chat section yes. Then I will give you some example of sparingly soluble salts. Sparingly soluble salt means what? They are not much soluble into the water or anything, right? Okay. So please have a note of some examples of sparingly soluble salts. Sparingly soluble salts. Write the example for sparingly soluble salts. What are the sparingly soluble salts? What are these sparingly soluble salts, guys? Please write sparingly soluble salts. What are they? That is what? First example is AgCl. Second example is AgBr. Third example is what? CaF2. CaF2. Then PbBr2. Sorry guys. PbBr2. Right? AlOH3. Next, MgOH2. These are what? Sprangly soluble salts. These are what? Sprangly soluble salts. So please have a note of these sprangly soluble salts because this will come in your examples. Written everyone? Is there any doubt? No? Fine. Now, significance of solubility product. So guys, please tell me, who will tell me what is this solubility product? What is this solubility product? Who will be going to tell me what is the solubility product? Is there anyone who can tell me about the solubility product? Solubility product, who will be telling me? Solubility product. DRT, can you please tell me what is the solubility product?
Sir, solubility product refers the product size, sir.
Yeah, refer to the
And
product side. So whatever be the multiplication of the product side, that will be KSP only, and that is also called as what? Solubility product. Is it fine? Solubility
yes, sir.
product is only that KSP. Whatever be the value for KSP that you are finding, that is only known as what? That is only known as what? That is solubility product as well. Is there any doubt? Till here, is there any doubt, guys? No? So I'm going to give you one example and please tell me that what will be the value of KSP in this case. The question is what? CaF2 is there. I have given you the example of CaF2, right? And it dissociates into what? Ca plus 2 ion. Ca plus 2 ion and what? 2F minus ion. 2F minus ion. See, guys, let the initial concentration is Sm, right? S mole. So their initial concentration will be what? 0 and 0 because in the starting the reaction is not happening, right? So after some time, what you will be going to see, we don't have to see this for CaF2, right? We are having what? S. And what will be the value for this 2? 2 if the coefficient is 2, so we can write a what? 2s. Getting my point? Is it okay? Now, if we have to find the value for KSP, if we have to find the value for KSP, concentration of Ca plus 2, concentration of Ca plus 2 plus concentration of what? Sorry, not plus, into concentration of what? Into concentration of 2F minus ion. Is it okay? Now, this time we also have to see what? Their coefficients. So you can see here their coefficient is what? Here you can see what? 1 is there. So for 1 we are not writing anything, right? But for 2 coefficients we have to write something. So can we write here what? Concentration of S to the power 1 and concentration of S to the power 2. Can we write like this or not? Please guys, please tell me. Can we write like this? Concentration of 2S to the power 2. 2S to the power 2, yes or no? Can we write like this? Is it okay? Right. Okay. Now, can we say it what? 2 to the 4, right? This will be what? 2 to the 4, 2s square will be what? 4s square. So, s into 4s square. So, it will be what? 4s cube. So, KSP value equals to what? 4s cube. Is it fine? Value for KSP equals to what? 4s cube. Fine, everyone. Is there any doubt? Is there any doubt? Then please tell me, guys. Please have a note of these things. Then please tell me. After this, if there is any problem, then please tell me. See guys, I'm going to give you one short trick to find the answer for this. Again and again you have to write all these things. So beside this, I'm going to give you one short trick to find the answer for this type of question, right? Let's suppose we are having AgCl. Let's suppose we are having what? AgCl. Fine. So there is one, we can write 1 because there is no any coefficient is there. So can we write 1 and 1, right? So x equals to 1 and y equals to 1. Fine. We are taking what? X and y. So x equals to 1 and y equals to 1. Is it fine? Is it fine, guys? So ASP equals to what? You have to write what? X to the power x, x to the power x, and y to the power y. Fine. That is equals to what? S to the power what? X plus y. Getting my point? S to the power what? S to the power x plus y. Any problem till here? So KSP equals to what? KSP equals to what? A value of x is what? 1. Value of x is what? 1 to the power what? 1. There is nothing is given. So 1. And y to the power what? Y, that is equals to what? 1. Again we have to write what? 1. So x, value of xy is what? 1. So value of s will be equals to what? 1 plus 1. Is it okay? So KSP equals to what? KSP equals to what? S square. If you want to find the value of s equals to what? Then under root KSP. Fine. Guys, if you can do from this, then it will be also an easy task for you. Try to understand from here and take a break of 5 to 7 minutes, then we will be back. Fine, everyone. Everyone is back. Yes, guys, please turn on your camera. I'm going to give you another question and please try to solve this question. And once you are done, then please tell me, then I will give you my short tricks as well. I will solve the questions according to my short tricks. Question is what? AlOH3 is there. What is the value of KSP that you have to find here? Value of KSP. You can take the help from this equation and you can use in the second question. Should I help you guys? Or you have done from your side only? Yes, Atacha, done. So what is your answer? (27s to the power 4). Yes, very good answer. Else, others, what is your answer? Mukeshwaran, Ashwin, Karthik, Bhuana, what is your answer, guys? How we can solve this question? How we can solve this question? I have given you one short trick. Short trick is what? X. We have to take this x. X equals to what? 1. And y equals to what? See, formula is what? X to the power x into y to the power y into s to the power x plus y. Isn't it? Into s to the power x plus y. Is it okay? Now here, what will be the value for y? What will be the value for y? Guys, see here, y will be what? Y will be equals to 3. Very good. Y equals to what? 3. So if y equals to 3, then can we find the answer for this question? So KSP equals to what? 1 to the power 1 into 3 to the power 3. What? What do you say? 1 to the power 1 into 3 to the power 3 into s to the power x plus y. So x plus y is what? 1 plus 3. Can we write 1 plus 3? Isn't it? So the right answer will be what? KSP equals to 1 into 3. That will be 3 only. And 3 to the power 3. 3 to the power 3 equals to what? 3 3 is 9. 9 3 is what? 27. 27. And s equals to what? S to the power 1 plus 4. So it will be equals to what? S to the power 4. So 3 3 is 27 to the power 27. S to the power 4 will be the right answer for this KSP. Is it fine? 27 s to the power 27 s to the power 4. This is the short trick. By short trick we have got this answer, guys. But if you will go to find by the conventional method, so how we can find by the conventional method? We have to first break into their dissociations. How we can dissociate this? So we will be doing like this. AlOH3 will dissociate into what? Al plus 3. So, so many of you will not be even able to write that how it will be dissociating into their ions, right? Constituent ions. So here will be what? It will be 1 and here it will be what? 3. Is it okay? So this is a long process. I have given you a short trick. Even for any compound, you can apply that trick and you will be getting the right answer for that question. Is it okay? Any problem till here, guys? No? No. Now, come to the point, significance of the solubility product. The first is what? The lattice enthalpy of the salt and solvation enthalpy of the ions in the solutions are most critical elements in determining the solubility. Second is what? When a salt is dissolved in a solvent, the strong force of attraction of the solute must be countered by interaction between the ions and the solvent. Getting my point? The third is what? Ion solvation enthalpy is always negative, indicating that energy is released during the process. Getting my point? So energy will be released during the process. Fourth point is what? The solvation enthalpy or the amount of energy released during the solvation is determined by the solvent's composition. And the fifth point is what? Because of non-polar solvents have low solvation enthalpy, this energy is sufficient to overcome the lattice enthalpy. So these are the some points, significances of the solubility product, guys. Now, one more point is what? Effect on solubility, right? Effect of temperature on solubility. We can increase the solute solubility by increasing the temperature. I have told you in the starting of the class, if the temperature will increase, solubility will increase, solubility product will be also increased. Yes. So we can increase the solute solubility by increasing its temperature. Water generally dissolves solutes at 20 degrees Celsius, 20 degrees Celsius, or 200 degrees Celsius, you can say. By increasing the temperature, soluble solids or liquid substance can entirely liquefied. However, in the case of gaseous substance, the temperature has an inverse effect on solubility. So in case of gaseous substance, see guys, let's suppose you are having water in this, and let's suppose you are having what? You are having what? Salt, or you are having sugar. If it is not mixing, then what you can do? You can just increase the temperature of this water, or you can boil that water, right? Then the solubility can increase, right? But in case of gaseous molecule, you are having a cylinder, that is LPG cylinder at your home. If you will increase the temperature, or if you do the, into fire, so what will happen? You can, I hope you all know that what can happen then after. Is it okay? So in the case of what? Gaseous molecules, the case is inverse. Getting my point? So if you will be increasing the temperature, then what will be happening in case of gas? That they will be having the lesser solubility in that case. Getting my point? So that we have seen. So what will be the effects on temperature in case of solubility? That we have seen, right? Now we are going to see another topic, that is what? Common ion effects. So what do you mean by common ion? What is the meaning of common? You are a student of mathematics. I hope everybody is knowing that what is common. Even you are using this term common in your square roots, and even in your what? That chapter, that is what? Linear equation, and after that what is coming? Quadratic equation. So in quadratic equation, in every equation you are taking some commons, right? When you are doing your by middle term split methods, when you have quadratic equation, you have to take what? Common in that, right? So while taking the common, so there must be two things same, that from there only you are taking anything common. So here in common ion effect, what will be that? Can anyone tell me what is this common ion effect? Anyone who can tell me what the common ion effect? What will be the common in this common ion effect? Anyone tell me what the common ion effect? No one can tell me anything. Sure. You will not telling me anything about the common ion effect. See guys, Yes, ion. Yes, Vishnu, tell me what is common ion effect? What are the common in the common ion effect?
I think in common
I'm
ion
going to give
effect
you
we
one
are
example.
taking
Yes, yes.
common out of iron, I think, sir.
Yes, I'm going to explain one for this. See, let's suppose we are having what CH3 COOH in aqueous solution, right? So this is what acetic acid. Acetic acid. This is what a weak acid, right? So in equilibrium, what will happen? It will dissociate into what? CH3 and COO minus ion, right? Is it okay? Okay. It will dissociate into what? CH3 COO minus ion and plus giving what? H plus ion concentration. Is it okay? It will be giving what? H plus ion concentration. Is it fine for everyone? No problem. Let's suppose we are having what? HCl. H plus HCl. So HCl, if you want to add HCl into this, so what will be there? HCl. So HCl will dissociate into what? HCl will dissociate into H plus and Cl minus ion. H plus and Cl minus ion. Yes or no, guys? Please tell me. So it will be giving what? H plus and Cl minus. So you can see here what is going to happen. Here H plus is there, right? Again you are getting what? H plus you are getting. So can this two be common or not? Please tell me that. This H plus and this H plus, they both are common. So what will be happening here? So if you will be going to add this, so see, you are getting this, you are adding this into this. So you can see here in the product side, the concentration of H plus will be increased or not? In the product side, the concentration of H plus will be increased, right? So you can see here Q will be increased. You have learned in the case of what? You might, if we have to find the Ka value, right? Equilibrium constant if you have to find, it will be equals to what? Concentration of CH3, right? And COO minus, yes, into concentration of what? H plus upon concentration of what? CH3, COO, H. Yes or no, guys? Please tell me. But due to this common ion, that is what? H plus ion, so the concentration of the numerator part will be increased or not? Please tell me, guys. If there is a common ion, that is what? H plus is there, so the concentration of the numerator part will be increased, right? So it means what? Q value is increased. We have seen in the case of Le-Chatelier principle, we have seen what? If the concentration is increasing, if the product side is increasing, but what will happen? What will happen? Their Ka will be not changing, right? So what will happen? The reaction will shift towards backside. Can we say that or not, guys? Please tell me. Their equilibrium constant will be not changing. So if the Q value is greater than, I have given you the formula. If Q is greater, then what will happen? The reaction will shift towards what? Backside. Yes or no, guys? So if Q is greater than Kc, then what will happen? The reaction will shift towards the backward side. Is it okay? Fine, everyone. So in this case, what will happen if the concentration of H plus ion increases? It means the numerator is more. If the numerator is more and denominator is less, so it means what? The product side is more. If the product side is more, and if we have to maintain this equilibrium constant, so what will be happening there? We have to move towards the backward side. Is it fine? Is there any problem till here? No. So this is what common ion effect. Now, see here, what is written here? I have given you with the, I have made you understand by giving an example. Now see here what is given here. And common example of ion effect is observed when a gaseous hydrogen chloride is passed through a sodium chloride solution, right? Leading to the precipitation of NaCl due to the excess of chloride ions in the solution brought in the dissociation of HCl, right? So don't take it serious. I have given you the best example, right? Is it fine? Any problem, guys? No. I'm giving you one more example, right? I'm giving you one more example. See here. So we have taken one example from this common ion effect. If I'm going to tell you, see guys, tell me who has understood these things very clearly. Atachaya, have you understood these things or not? Please tell me. Anyone is having any problem? Vishnu Priya, have you got this? What is this common ion effect? If I will go to ask you to, understand and other people, will you be able to understand? Will you be able to make them understand or not about the common ion effect? Yes or no? Please tell me. Will you be able to make understand what is this common ion effect? I am giving you one another example, right? This time we are having what? AgCl. AgCl is there, right? So it will dissociate into what? Ag plus and Cl minus plus Cl minus. Yes or no, guys? Please tell me. Ag plus and Cl minus, right? Now, let's suppose any strong electrolyte, that is what? Na plus and Cl minus is there again. Na plus and Cl minus is coming. So if we can see here, again here Cl is there and here Cl minus is there. Cl minus and Cl minus are there. If any electrolyte is adding into this, so there what will be the change in there? What will be the change in that? See here. If we want to find K, so what will be the K for that? What will be the K for that? This will be what? Concentration of Ag plus concentration of Cl minus into concentration of Cl minus upon concentration of AgCl, right? Is it okay? Now the value has what? The Cl ion has increased here. They are having common ion. Common ion has been increased here. So what will happen again? The QSP value will be increased. Q value will be increased. So if Q value will be increased, then what will happen again? If Q value will be increased, then what will happen? The reaction will shift towards backward side. Is it okay? Any doubt? Any problem till here? No? Okay. Now, see here what are indicators. So guys, you might be knowing this indicators. Everyone, cars, bikes, they are having what? Indicators. But this is not that indicator. This is somehow different indicators, right? So what is this indicator? So what is this indicator, guys? What is this indicator? Can anyone tell me indicator? See here. Indicator are substances whose solution change color due to change in pH. Yes, Vishnu Priya, somewhat that is correct. These are called acid-base indicators. They are usually weak acids or bases. But their conjugate base or acid forms have different colors due to difference in their absorption spectra, right? Now I'm going to give you one example first, and you have to solve that. First, can anyone tell me the answer for this question? And after that, one question is ready for you. I'm going to give you one more question. Write your answer in the chat box, guys. So guys, what will be the conjugate acid for this? Which of the following is the conjugate acid of NH2 minus, right? So many answers has been there, guys. So what do you say? What will be the right answer for this question? What will be the right answer for this question? Vuana NH3. Vuana has written NH4 plus first. Atacha NH3 and H plus. Vishnupriya H plus. So what will be the right answer? Who is confident to explain this question? Who is confident, guys? What do you say? Atachaya. NS3. Are you sure? Anyone else? Okay, fine. So conjugate acid will be what? NS3. Okay, fine. So guys, I am going to give you one more question. Try to solve that. Please write this question. I am going to dictate you. Please write this question. Question is what? Calculate the solubility of A2X3. Calculate the solubility of what? A2X3. A2X3. Fine. In pure water, assuming that neither kind of ion reacts with water. Neither kind of ion reacts with water. Right? The solubility product of A2X3. Solubility product of A2X3, comma, KSP equals to 1.1 into 10 to the power minus 23. KSP equals to 1.1 into 10 to the power 1.1 into 10 to the power minus 23. Minus 23. So KSP value has been given to you. Is it okay? So now try to solve this question.